Hello guys, welcome to my YouTube channel. Today we are discussing about the analyze the working of wireless cellular network. Introductions to wireless cellular networks. Wireless cellular networks connect the mobile devices to the internet and other devices, and they utilizes in a series of base stations to cover in a geographical areas. Understanding their operation is crucial for effective communication technologies. The history of cellular networks. The first generation introduced analog voice communications in 1980s. Subsequent generation advanced to digital communications and data service. Each generation has progressively improved data speeds and reliabilities. Basic components of cellular networks. The main components include of mobiles, devices, base stations and mobile switching centers. The base station transmits and receives the signals and from the mobile devices. Mobile switching centers manages the calls and the data sessions within a network. Frequency reuse. The frequency reuse allows the multiple users to share the same frequency band. This is achieved by dividing a coverage area into smaller areas, and it is significantly increases the capacity of a network. Cell structures. The cell structures is typically a hexagon, and the cell was served by the base stations and magnified frequency. Handover mechanism. The handover mechanism refers to the process of transferring ongoing call from one cell to another. This is essential for maintaining calls as users and move through different coverage areas. There are various types of handovers, including hard and soft handovers. Modulations techniques. The modulations techniques are used to encode the informations into carrier signals. The common techniques, which is known as QPSK and QAM, quadrature phase shift key, and also quadrature amplitude modulations. The choice of a modulation affects the data rates and reliability of the connections. Multiple access techniques. The multiple access techniques allows multiple users to share the same communication channel. The common methods include an FDMA and a TDMA, and CDMA is also widely used in providing unique codes for each users. Network architecture. The cellular networks are classified into mainly two architecture, which is known as centralized and decentralized. The centralized architecture has a core network which manages traffic routing, and decentralized allows the more direct device to device communications. So here there is an example which is known as client servers or a P2P. The role of base stations. The base stations are crucial for connecting the mobile devices to cellular network. They are equipped with antennas that transmits and receives the radio signals. The base stations also handles signal processing to enable communications. Quality of a service, which is known as a QoS, where it refers to an overall performance of the cellular network as perceived by the users. It includes the matrices like latency, bandwidth and error rates. Ensuring a high QoS, it is vital for user satisfaction and service reliability. Network coverage. Network coverage depends upon the density and placement of base stations. The urban areas requires more base stations due to the higher user density. The coverage is also enhanced with the uses of repeaters and small cells. Interference management is a significant challenge in a cellular network, affecting signal quality, and techniques like power control and frequency planning are used to migrate the interference. Advanced algorithm can help the manager interference dynamically in a real time. Security in a cellular network. Security is vital to protect the user data and communications from threats. Encryption protocols are implemented to safeguard the voice and data transmissions. Authentication process ensures that only the legitimate users can access the network. Evolutions towards 5G. The transitions to the 5G networks promises a faster speeds and a low latency. 5G utilizes an advanced technology like an MIMO, which is known as massive technology, and a beamforming. These evaluations aims to support emerging applications such as an IoT and smart cities. Impact of an IoT on a cellular networks. IoT is an increasing number of connecting devices, and a cellular network must evolve to accommodate the unique requirements of an IoT device. The low power wide area networks, which is an LPWAN, are being developed for IoT use cases. Future trends in a cellular networking. The future trends includes an integrations of an AI and a network management and optimizations. There are a growing emphasis on an energy efficient and sustainable network solution. The development of a satellite-based cellular network is also one on rise. Thank you.